Hi guys, ako nga pala si Ramin Magbo from IT2102 and today I will discuss Chapter 8 in CNE 1 version 2.0 and let's get started. This Chapter 8 is entitled by Subnetting the IP Networks and then this chapter tackles about the subnetting the IP networks. It is designing, implementing, and managing an effective IP addressing plan ensures that network can operate effectively and efficiently. This is especially true as the number of host connections to a network increase. Understanding the hierarchical structure of the IP address and how to modify the hierarchy in order to more efficiently meet routing requirements is an important part of planning an IP addressing scheme. In the original IPv4 address, there are two levels of hierarchy, a network and a host. These two levels of addressing allows for basic network groupings that facilitate the routing packets to a destination network. A router forwards packet based on the network portion of an IP address when the network is located. The host portion of the address allows for identification of the destination devices. However, as networks grow, with many organizations adding hundreds and even thousands of hosts to their network, the two-level hierarchy is insufficient. Subdividing a network adds a level to the network hierarchy, creating, in a sense, three levels: a network, a subnetwork, and the host. Introducing an additional level to the hierarchy creates additional subgroups within the IP network that facilitate faster packets delivery and added filtration by helping to minimize local traffic. In this chapter, examine in detail the creation and assignment of IP network and subnetwork address through the use of the subnet mask. The broadcast domains having the other devices, service devices, and an internet or the Ethernet LAN devices use broadcast to locate. Switches propagates broadcasts out of interface except the interface on which it was received. For example, if a switch in the figure were to receive a broadcast, it will be forward it to the other switches and other users connected into the network. The other one is the problems with large broadcast domains. A large broadcast domain is a network that connects many hosts. A problem with a large broadcast domain is that these hosts can generate excessive broadcasts and negatively affect the network. Reasons for subnetting. Subnetting reduces overall network traffic and improves networking performance. It also enables an administrator to implement security facilities or the policies such as which subnets are allowed or not allowed to communicate together. The octet boundaries. Every interface on a router is connected to a network. Subnetting on the octet boundary. To understand how subnetting on the octet boundary can be used, considering the following example. Assume that the enterprise has chosen the private address that 10.0.0.8 is equals to an internal network address that this address can connect 16,000 or 16,777,214 hosts in one broadcast domain. Obviously, this is not ideal. The classless subnetting. For each bit borrowed in the port's octet, The number of subnetting available is doubled when reducing the number of host address per subnets. Classes subnetting example. To understand how subnetting at a class level can be useful, considering the following example. Consider the private network address is shown in the figure 1. The first three octets are displayed in decimal. And then, while the last octet is displayed into the binary. The reason is because we'll be borrowing bytes from the last octet to create subnet of the 192.168.0/24 network. Creating two subnets. This is the IPv network host, or the IPv network address is the host. What is the subnetting formulas? To calculate the number of subnets that can be created from the bits borrowed, use the formula displayed in figure 1. This is the n is equals to bytes borrowed, and then in figure 2 is calculate the subnetting, display the possible numbers of subnets that can be created when borrowing 1 to 5 or 6 bytes. In sub 3, um, it shows that the 2 or equals to n equals to the number of bytes remaining in the host field. And last, it's shown in the figure 4, there are 7 host bytes remaining. So, to calculate this, 2 raised to 7 equals to 128 minus 2 equals to 126. Why? Because this means that each subnet has 126 valid host address. Creating the 4 subnets. In this figure 1, the enterprise using the private network address 192.168.1.0/24 range and requires the 3 subnets. Borrowing the single bit only provides 2 subnets, therefore another host bit must be borrowed as shown in the figure 2. This is the figure 2. This is the borrowing using the formula 2 raised to n formula. Results is 2 over 2. 2 raised to 2 is equals to 4, and then 4 is equals to the subnets. And then in the figure 3, the resulting subnet mask of over 26, or 255.255.255.192 is used by all 4 subnets. And to calculate the number of hosts, examine the shown in the figure 4. This is the figure 4. After borrowing the 2 bytes or the subnet, there are 6 host bytes. Therefore, we can apply the host calculation formula. 2 raised to n equals to, as shown to reveal the subnet, can support 62 host address. And then this is the 5 and 6 and 7. Creating subnet with the 16 prefix, calculating the host, and a lot of more. So, in conclusion of this chapter, the process of segmenting a network by dividing it into the multiple smaller network and space is called subnetting. Every network address has a valid range of host addresses. All devices attached to the same network will have an IPv4 host address for that network and a common subnet mask or network prefix. Traffic can be forwarded between the hosts directly if they are on the same subnet. Traffic cannot be forwarded between subnets without the use of a router. To determine if the traffic is local or remote, the router uses the subnet mask. The prefix and the subnet mask are different ways of representing the same thing. the network portion of an address, and the IPv4 subnet are created by using one or more of the host bytes as network bytes. Two very important factors that will lead to the determination of the IP address block with the subnet mask are the numbers of subnetting required and the maximum number of hosts needed per subnet. There is an inverse relationship between the numbers of subnet and the numbers of hosts. The more bytes that are borrowed to create subnets, the fewer host bytes that are available. Therefore, there are fewer hosts per subnets. They have a formula that 2 ways to n, where the n is the number of host bytes remaining is used to calculate how many addresses will be available on each subnet, and however, the network address and broadcast address within a range are not usable. Therefore, you can calculate using 2 raised to n minus 2 is required. Subnetting a subnet or using variable length subnet mask or the BLSM was designed to avoid wasting address. IPv6 subnetting requires a different approach than IPv4 subnetting, and IPv6 address space not subnetting to conserve address. Rather, its subnetting is to support the hierarchical logical design on the network. So, while IPv4 subnetting is about managing addressing scarcity, and then IPv6 or the subnetting is about building an addressing hierarchy based on the number of routers and the networks they support. Careful planning is required to make the best of use that available address space, size, location, use, and access. Requirements are all considerable in the address planning process. After it's implemented, an IPv network needs to be tested to verify its connectivity and operational performance. This is the last or the summary version 2.0 and it's done. Thank you for listening.